Okay, so hello, good evening, everyone. Welcome to the interview preparation session by 360 Digital MG. Let me share my screen. Today, we are going to learn about logistic regression. Interview question on logistic regression. So, first question is, what is logistic regression? First of all, we need to learn what is logistic regression. Interviewer might ask that what is logistic regression. So, logistic regression is a statistical analysis method used to predict a data value based on prior observation of a data set. In simple terms, a logistic regression model predicts a dependent data variable by analyzing the relationship between one or more existing independent variables. You can say like example to identify to predict the possibility of like events such as pass or fail, if a student is going to pass or fail, if a student is going to win or lose, is he alive or dead, healthy or sick. So this kind of probabilistic questions is done by using logistic regression. Second question, what is one versus all method in logistic regression? What is one versus all method in logistic regression? I'm writing logistic regression. So, what is one versus all method? So, if there are n number of classes, then n separate logistic regression has to fit where the probability of each category is predicted over the rest of the categories combined. So, this is done by the one versus all method. To do this, we use this one versus all method, where the probability of each category is predicted over the rest of the categories combined. So, one versus all, as the name is defining. The probability of each category is predicted over the rest of the categories. Third question. What do we estimate for one each unit change in X? No, we can skip this question. Okay. What makes the interpretation of conditional effects extra challenging in logistic regression? What makes the interpretation, just read the question carefully and then listen what am I saying. What makes the interpretation of conditional effects extra challenging in logistic regression? What makes the interpretation of conditional effects extra challenging in logistic regression? So, the conditional effect is dependent on the values of all the x variables. X variables means input variables. Okay, so the x variables. Next question. So this makes the interpretation of the conditional effect a little bit extra challenging. Why? Because all the values are dependent on input variables. This makes it extra challenging. Next question. Why multinomial logistic regression is often considered an attractive analysis? Why multinomial logistic regression often considered as attractive analysis? Why multinomial logistic regression, often considered as attractive analysis. So, multinomial logistic regression is often considered as attractive analysis because it does not or homoscedasticity. The regression is used more frequently than discriminated function analysis because the analysis does not have such assumptions. That is why this multinomial logistic regression is attractively used above all the functions. Why? Because it does not assume such assumptions like homoscedasticity, normality, linearity. All these assumptions are not assumed in this multinomial logistic regression. Next question. Which function is used to transform the output probability in 0 to 1 range? Which function is used to transform the output in 0, 1 range? There are multiple functions available in logistic regression. So among them, which function is used to transform the output in 0 to 1 range? So we can use sigmoid function. If we want our output in the 0 to 1 range, we can use sigmoid function. There are multiple functions available like 10 hair function, depending on the range. It totally depends upon the range we want our output in. Accordingly, we use different functions. So we can use both sigmoid and 10H function instead of sigmoid function for logistic regression. But if you want your output in this 0 to 1 range, we go for sigmoid function. And we can use 10 function if we want the range in, say, -1 to 1. If we want our output in that range, we resort to 10H function. Okay. Next. Next question is, which function is used for solving the problem of density estimation? What do we use if we have to choose the values for the parameters of logistic regression? Let me write the question. What is used to choose values for the parameters in logistic regression? What is used to choose values for the parameters of logistic regression? What do we use? We use maximum likely estimation, MLE. We use maximum likely estimation to choose value for the parameters. As why? Because it is a probabilistic framework for solving the problem of density estimation. Whenever you are having problem of density estimation, we always go for maximum likelihood estimation. It is best to choose values for the parameters. Next question. Is logistic regression a supervised method machine learning algorithm is logistic regression, a supervised machine learning algorithm. So the answer is yes, it's true. The logistic regression is a supervised machine learning algorithm. Why? Because it uses true labels for training. Supervised learning algorithm should have input variables and then a target variable when you train the model. So logistic regression is a supervised machine learning algorithm because it also has input as well as target variable X and Y variable. When we train the model using logistic regression, we have input variables as well as target variable. That is why it is a supervised machine learning algorithm. Which model evaluation matrix is used for logistic regression? Which model evaluation matrix is used for logistic regression? The answer is AUC-ROC curve. This is used by logistic regression is a classification algorithm. So its output cannot be real-time value. So mean square error cannot use for evaluating it. That is why we don't use mean squared error. We go for ROC curve. So which model evaluation matrix is used? ROC curve. Here we do not use mean squared error. Why? Because logistic regression is a classification algorithm, so the output cannot be in the real-time value. That is why. Next question. Is it possible to apply a logistic regression algorithm on a three-class classification problem? Is it possible to apply logistic regression on a three-class classification problem? So, is it possible to apply a logistic regression algorithm on a three-class classification problem? Yes, it is possible. We can apply logistic regression on a classification problem. Three-class classification problem. We can use one versus all method. Which method we can use? We can go for one versus all method. Next. Why can't we use mean squared error on logistic regression? Over here, I tell you now that we use ROC curve for model evaluation. So, why can't we use mean squared error? Why can't we use mean squared error on logistic regression? Why? Since logistic regression is the classification problem, so its output cannot be real-time value. So that is why we cannot use mean squared error for evaluating it. That is why we go for AUC-ROC curve. Clear? Next. Why is logistic regression better? Or in short, advantages of Logistic regression. What are the advantages of? What are the advantages of logistic regression? Why is it better than other regression models? So, first, it is easier to implement. Second, easier to interpret. Third, very efficient to train. So, all of these are the points that why logistic regression is better. Or you could say all these are the advantages of using logistic regression. Logistic regression is easier to implement, interpret, and very efficient to train. The number of the observation is lesser than the number of features. Logistic regression should not be used. This is the condition that if the number of observation is lesser than the number of features, then we should not go for logistic regression. It may lead to overfitting. So we should avoid using logistic regression whenever we are having number of observation lesser than the number of features. Next question. What is the difference between binary and multinomial logistic regression? What is the difference between binary and multinomial logistic regression? What is the difference between binary and multinomial logistic regression? So, multinomial logistic regression deals with the situation where the output can have 3 or more possible types. We can go for multinomial where the output or the outcome can have 3 or more possible types. Multinomial logistic regression deals with the situation where the outcome can have 3 or more possible types. Example, like let's say if someone is having a disease like disease 1, disease 2, disease 3 or multiple diseases, then we should go for multinomial logistic regression. And when we just have to find out that the person is having fever or not, then we have to go for binary logistic regression. So, binary logistic regression is used to predict the odds of being a case, that whether the person is having a fever or not, based on the values of independent variables. That means the predictors. So, this is the difference between binary and multinomial logistic regression. Next question. When to use logistic regression? When to use logistic regression? So, when should we go for logistic regression? When we want to predict a continuous variable. Predict any categorical variable from several other categorical variables. In that situation, we have to use logistic regression. In that case, we should use logistic regression. When we want to predict a categorical variable from several other categorical variables. Okay. Next question. What is the loss function in logistic regression? So what is the loss function when it comes to LR or in LR? Anything you can say. We just have to say what is the loss function. So loss function is sum of squared error, SSE. This is the loss function used in the LR. When we solve logistic regression problem, when we have to find out the loss, when we have to use the loss function, we go for SSE, sum of squared error. This is the loss function used. Next question. what would you do if you want to train logistic regression on same data that will take less time as well as give similar accuracy? What would you, let me write, what would you do? What would do if you train logistic regression on same data that will take less time as well as give comparatively similar accuracy. Accuracy may not be same but similar. So what do we do in such case if we want to train a logistic model on same data that will take less time as well as give similar accuracy? So we increase the learning rate and decrease number of iterations. This we can do to get a result in the less time as well as with similar accuracy. I'm not saying same accuracy. I am using similar word because the accuracy may differ. So through which we can get this by increasing the learning rate and decreasing the number of iteration. Vice versa. Learning rate and number of iteration we have to do vice versa. Increase the learning rate and decrease the number of iterations. Next question. What are the assumptions made in logistic regression? There are multiple assumptions that we made in logistic regression, so we have to tell what are those. So, first of all, logistic regression assumes that there is minimal or no multicollinearity among the independent variables. These are the assumptions. I'm just stating all the assumptions made in LR. First, that there is minimal or no collinearity among the variables, independent variables. Second, there should be a linear relationship between the logic output and each predictor variables. Third, it requires a large sample size to predict properly. All are the assumptions made in LR. The LR assumes the to be independent of each other. This assumes that the dependent variable is binary and ordered. Logistic regression requires the dependent variable to be ordered. That it should be in the ordered logistic regression. For example, you can say too little, about right, too much. These are the examples. These all are assumptions that are made in logistic regression. Question. Why is logistic regression called regression, not classification? Why logistic regression called regression and not classification? You can say no, this is the only name, we can give any name. No. If it is called logistic regression, there is a motive. There is a logic. And what is that? Why it is not called logistic classification? Why it is called logistic regression? Because the main difference between regression and classification. What is the main difference between them? So the main difference is that the output variable in regression is numerical, continuous, right? While that for classification, it is categorical or discrete. Anything you can use like categorical or discrete or numerical or continuous. So logistic regression is basically a supervised classification problem algorithm. However, the model builds a regression model just like linear regression to predict the probability that a given data entry belongs to the category numbered as 1. That is why it is called regression. So logistic regression is a supervised classification algorithm only. So here the model builds a regression model just like linear regression to predict the probability that a given data belongs to the category numbered as 1. Next, explain the significance significance of sigmoid function. We need to explain the significance of sigmoid function. We know that we use sigmoid function when we want our output in the range of 0 and 1. But what is the significance? What is the use of sigmoid function? Why do we use that function in our model? So sigmoid function is used to eliminate the effect of outliers. What it do? It eliminates. It removes the effect of outliers. It does not remove the outliers. It removes the effect of it. The outlier is still present in your data set. It just removes the effect of it. So it doesn't matter if your outliers are present in your data set or not. It will just remove the effect. So this is the significance of sigmoid function. There is also one more significance that it is used in order to map the predicted values to probabilities. That is why we use sigmoid function, but it also eliminates the effect of outliers. And its range is between 0 to 1. Next question. Can the cost function used in the linear regression work in logistic regression? Can the cost function in linear regression, there is one cost function we used in linear regression. So the question is that, can we use this cost function in the logistic regression or not? Can the cost function in linear regression work in logistic regression as well? Okay, logistic regression. So the cost function used in linear regression cannot work with logistic regression. No, we cannot use this cost function in logistic regression. We use the squared error mechanism. What do we use? We use the squared error mechanism. Unfortunately, for logistic regression, such a cost function, why we don't use this cost function? Because this cost function produces a non-convex space that is not ideal for optimization. That is why we don't use this cost function. Instead of this cost function, we go for squared error mechanism. And there is a reason of not using this cost function. And what is that? that it produces a non-convex space, which is not ideal for optimization. This is the reason of not using this cost function and go for squared error mechanism because it does not produce that space. So for that we can, which is ideal for optimization. Next question. Can you use logistic regression for classification between more than two classes? Can you use logistic regression for classification between more than two classes? I hope many of you know the answer. Yes, we can use. It is possible to use logistic regression for classification between more than two classes. And what is it called? It is called as multinomial logistic regression. We have discussed this thing. That whenever the classes are more than two, it is called as multinomial logistic regression. However, this is not possible to implement without modification. So we need to do the modifications to model, to logistic regression model. We need to do some modifications. Then only we can use this multinomial logistic regression. Clear? Next question. How do you implement MLR, multinomial logistic regression? How do you implement multinomial logistic regression? How do you implement multinomial logistic regression? So the multinomial logistic classifier can be implemented using a generalization. It can be implemented using a generalization of sigmoid, which is called as softmax function. And what does this softmax function represent? This softmax represent each class with a value in the range 0 to 1. Because we are using a generalization of the sigmoid. That is why it represents each class with a value in the range of 0 to 1. With all the values summing up to 1. Alternatively, you could use the 1 versus all method or 1 versus 1. Using multiple simple binary classifiers. There is another method to implement multinomial, and what is that? 1 versus all or 1 versus 1. You could also use these approaches to implement MLR. MLR is not multilinear, it is multinomial logistic regression. Next question. What alternative could you suggest using a for loop when using a gradient descent to find the optimum parameters for logistic regression? That's a quite large question. What alternative could you suggest using a for loop? And that alternative should be using a for loop. And for which we want alternative? And using gradient descent. Okay, spelling mistake. Yeah. To find the optimum parameters for Logistic regression. We need to find an alternative that we can suggest using a for loop, and that alternative should be using a for loop when using gradient descent to find the optimum parameters for LR. So the answer is one commonly used efficient, that is also efficient alternative to using for loop is vectorization. This is commonly used and efficient also. What is that alternative? Is vectorization. That means representing the parameter values to be optimized in a vector. What do we do in vectorization? We represent the parameter values to be optimized in a vector. By using this approach, all the vectors can be updated instead of iterating over them in a for loop. Here, instead of iterating them using a for loop, all the vectors can be updated. This is the concept used in vectorization. It represents the parameter values to be optimized in a vector. And in this, by using this, all the vectors can be updated instead of iterating over them in a for loop. Next question. Which is the best method to fit the data in logistic regression? What is the best method to fit the data in logistic regression? What is the best method to fit the data in the logistic regression? So the answer is maximum likelihood estimation. This is the best method to fit the data in LR, logistic regression. Why do we use maximum likelihood estimation? To obtain the model coefficients which relate to the predictors and target, X and Y variables. To obtain the model coefficients which relate to the predictors and target variables. Next question. How to add new features in the same data by using a logistic regression model. How to add a few features in the same data, where we have used the logistic regression model. In that model, we have to add few new features, where we got the training accuracy X and testing accuracy Y. So how do we add few new features in the same data? Not by creating new data set. So training accuracy increases. Testing will increase or remain the same. This is what happens. Adding more features to model will increase the training accuracy. What happens when we add new features in the data? Or you could turn this question like this also. This question can be asked like this also, that what happens when you add new features in the same data? What happens? Change this question. What happens when we add new features to the model? What happens? The model will increase the training accuracy. By adding more features to the model, it will lead to increase the training accuracy, because the model has to consider more data to fit. Why it increase the training accuracy? Because the model has to consider more data to fit the logistic regression. But testing accuracy increases if feature is found to be significant. What happens? The training accuracy will definitely increase, but there is a doubt in testing accuracy. Why? Testing accuracy will increase or remain the same. And when will it increase? If the feature is found to be significant, only then it will be increased. Otherwise, it will remain the same. And for the training accuracy, it will increase anyhow. Whether the feature is significant or not, it will increase. So that this happens when we add more features to the model in the same data, not creating different data set or something like that. Clear? So this is it. We have covered all the questions of logistic regression interview by the interviewer.